This is another practice problem on operational amplifiers, and in this question we have to find out the voltage gain AV, which is equal to V0 divided by V1 minus of V2, and the op amps considered in this circuit should be treated as ideal ones. So V1 and V2 are the two input voltages, and V0 is the difference between the output of the top op amps minus the difference between the output of the bottom op amp. Or in other words, V0 is equal to V01 minus of V02. So looking at this problem, we can identify that this is actually the input section of an instrumentation amplifier, in the sense that the second stage of the instrumentation amplifier will comprise of a difference amplifier section, and so that difference amplifier will further amplify the difference between these two voltages. So with this question, if we look at the information that is provided to us, we know that because this voltage is at V1 volts, then the voltage at the other node, that means the voltage at the inverting input terminals node, will also be at V1 volts because of the concept of virtual short. And in a similar manner, because the non-inverting input terminal for this bottom op amp is at V2 volts, similarly the voltage at the inverting input terminal at this node will also be at V2 volts. So basically, if this is our circuit, then we have already identified that the voltage at this node will be V1 and the voltage at this node will be V2. Secondly, we also know that with an ideal operational amplifier, no current can enter the input terminal of the op amp. And therefore, if we consider that this is one node from where, let's say, a current I is flowing, then that current I should flow through the 6 kilo ohm resistance. It cannot take this path because the op amp will offer infinite input resistance, and therefore this current I will then flow through this 2 kilo ohm resistance. Similarly, it cannot enter the input terminal of the op amp for this bottom one also, and then the only possible path for this current to flow through is through this 4 kilo ohm resistance into the output of the second op amp. So basically this is the path of the current I if it flows from the node V01 to this node whose voltage is V02. And therefore we can formulate the expression for this current I. So let's say this is the start node and this is the end node, and therefore it can be formulated as voltage divided by resistance. So the voltage difference will be V01 minus of V02, and the resistance of this entire path will be 6 kilo ohms in series with 2 kilo ohms in series with 4 kilo ohms. So this will be 6 kilo ohm plus 2 kilo ohms plus 4 kilo ohms, and therefore the current I can be denoted as V01 minus of V02 divided by 6 plus 2 plus 4, which is equal to 12 kilo ohms. Again, if we look at the path for this current I, we can formulate another equation also, where we consider V1 and V2. And therefore we can write the current I's expression as voltage at this node being V1 minus of voltage at the other node being V2 divided by the resistance, which is equal to 2 kilo ohms. Note that the same current that is flowing through the 6 kilo ohm resistance is also flowing through the 2 kilo ohm resistance and then through the 4 kilo ohm resistance. So therefore V1 minus V2 by 2 is the other equation for the current I. Now the only thing that remains is to equate these two equations, and once we do that, we can write it as V1 minus V2 by 2 must be equal to V01 minus of V02 divided by 12. But then we already know that V0 is equal to V01 minus of V02, so this is equal to V0 by 12. And proceeding with the voltage gain expression, we can write V0 by V1 minus of V2 is equal to 6. So the idea of this question is very simple, and this is how actually we do solve for the expression for V01 and V02 of an instrumentation amplifier as well.